Let's go through the notes here real quick, and then we'll go start doing some problems together. And then, like I said, we'll do the quiz at the end of the hour. But this process that we're going to be doing, like I said, is going to be this entire chapter, but it's not just going to be done when we're done with the chapter. This is a process that you're going to do over and over and over again, pretty much in every math class that you ever do. So we're going to talk about factoring, and today we're going to start talking about factoring out what we refer to as greatest common factor. So we've already talked about doing multiplication and ending up with a product. We've already done that before, right? Where we did the distributive property. We had one polynomial multiplied by another. That's actually on your quiz today, right? What we're going to do is basically in this particular chapter is that process in reverse. Rather than putting things together, we're going to pull them apart. So the parts that we're going to pull them out into, we're going to refer to as factors. Sometimes they're also called divisors, but we'll call them factors. The idea is that we're trying to break down a complicated thing into more manageable pieces. That's the whole point of doing this process. Okay? It has lots of different applications in lots of different areas of math. For our purposes, we'll be worrying about more solving equations. That'll be kind of our main thing that we'll end up getting towards the end of the semester. Okay. The process that we're going to do of the reversing the idea of multiplying things together is what we refer to as factoring. And like I mentioned, we're going to be doing lots of factoring techniques in this chapter to get us ready to use all of these factoring techniques later on to help us solve more involved problems. So the first type of factoring that we're going to do in this chapter is referred to as factoring out a greatest common factor. So if we look at these numbers 12 and 20, let's just list out the factors here. What numbers go into 12? Yeah, 6 does, good. What else does? 3, I heard. 4. What else does?
1.
Yeah, 1, 2, 12, right? I think that's it. 1 times 12 will give you 12. 2 times 6, 3 times 4, and I think that's all we have. How about 20? What goes into 20? 5, a 4, a 2, 10, good. A 1 and a 20 again, right? You know, for certain, we know that 1 goes into everything, and then everything will go into itself, right? We're also looking for the smaller pieces together. And again, I think that's it for getting those factors. All right, so what we listed out there were the factors of 12 and the factors of 20. We want to know which is the biggest. What's the biggest number they have in common? 4, right? We notice that they have 1 in common, and they have 2 in common. So those are common factors, but the biggest one that they have in common is that 4. Okay? So that's what we refer to as the greatest common factor, or the GCF of 12 and 20 is 4. Good. And this is pretty much the only process that we have right now for figuring out the greatest common factor of 2 numbers. Is look at the factors of the first one, look at the factors of the second one, figure out what they have in common, and grab the biggest. For variables, we can do the same kind of idea. Let's look at how these would be written out longhand and then see if we can figure out what the greatest common factor is. So let's look at the x cubed times y to the 7th. Of course, the x cubed means we're going to multiply x by itself 3 times. And the y to the 7th would mean be y times itself 7 times, right? We agree with that? Likewise, when we have the x to the 4th, y to the 5th, we'd have x 4 times and y 5 times. So what we're trying to find when we do the greatest common, we're not going to do this process every time. I'm going to show you where it's coming from. When we do this, looking at both of these, we want to try to find the greatest common factor. Well, certainly both of them have an x in common, right? So x would be a common factor. They both also have a y in common, so y would be a common factor. But it's not the greatest common factor, right? Because not only do they have one x in common, how many total x's do they have in common? 3, right? And not only do they have one y in common, how many y's do they have in common? 5, right? So we notice that, let's see if I can change my color here. Maybe. Notice that we've got x's in common here. There's 3 x's in common. And we have 5 y's in common for both of them, right? So our greatest common factor here, the GCF of x cubed y to the 7th and x to the 4th y to the 5th is, we would have x cubed because that's in both of them, y to the 5th because that's in both of them. Notice how that corresponds to the original one. I look at x cubed and x to the 4th. Which of those exponents is smaller? 3, right? There's an x cubed in both of them, right? If I look at y to the 7th and y to the 5th, which one's smaller again? Y to the 5th, I fit both of them. Okay. So again, it has to be a common factor, it has to be in both. So we want basically the highest power of x, the highest power of y that goes into both of them at the same time. All right, so let's talk about how we pull those out. So that's what the next example has for us here. It says to find the greatest common factor, we want to find the common factor of the coefficients and the common factor of the variables. The greatest common factor of those. So let's ignore the x's to start with. Let's look at 3, 12, and 6, the different coefficients that we have on those x's. Do you see something that divides all 3 of them? 3 does, right? So does 1, but the biggest thing that divides all 3 of them is 3, right? So whoa, that was weird. Yeah, that's going okay. When we have the 3x cubed plus 12x squared plus 6x, the idea behind this greatest common factor and factoring it out is that I want to pull out anything that's in common to the front. Basically, we're reversing the distributive property. So we'll pull out a 3 for that. Now look at the variables. Do you see anything that all the variables parts have in common? An x, right? So we can pull that out too. Okay. Oops. Now what's left? Well, if I take the 3 out, basically dividing out the 3, what's left for the coefficient? Just a 1, right? If I take out the 3, there'd be a 1 left. Here, if I take out the 3, there would be 4 left. If I take out 3 out here, there'll be a 2 left, right? We're basically dividing each of those coefficients by that number. Okay. We're also taking out an x. So out of that first term, how many? If they take 1x out, how many will be left? 2, right? So the first term will be just x squared all by itself. How about the second part? We said when we took out a 3, we're left with what for the coefficient? A 4. We took out 1x, so we'll be left with just an x. And then for the last one, we took out a 3, so we're left with 2. We take out the x. And we just have no x's left in there, right? We took the only x out that there was. So we will close off the parenthesis there. One of the nicer things about factoring is that you can always check your answer. You can always check your answer by redistributing it and see if you got back where you started. You can always check it. Questions on that one? All right. Let's look at the next one. Asks us to factor out the GCF for each of them. Again, looking at the numbers. Look at the numbers I always look at the coefficients and then the variables. Do it in stages. I look at the 5 and the 15. What do the 5 and 15 have in common? A 5, good. Now let's look. I've got an x squared and an x. Let's do the variables one at a time. If I look at the x squared and the x, what does that have in common? An x, good. And if we look at the y and the y squared, what do they have in common? A y, good. So your GCF here is 5xy. Everybody okay with where we got that? Okay. All right. So now let's go term by term. We pulled out a 5, so it leaves a coefficient of 1. We pulled out 1x, so that leaves x. We pulled out y, that just leaves 1 again, right? So what's the first term just going to be? Just x. Good. We pulled out 5, so we leaves it for the number. We leave a 3. Pulled out x, that leaves just a 1, right? Pulled out a y, we're left with y. Good. So far, so good? Okay. Let's look at the next one here. Again, I always like to do the numbers first, then go to the variables. What is something that divides the 6 and divides the 8 and divides the 12? 2, right? 2 divides 6, 2 divides 8, 2 divides 12, and nothing else bigger does, right? Okay. So the GCF of just the coefficients will be 2. How about for the x's, what can you pull out? Yeah, just an x, right? And for the y's, just one y again, right? Now notice this last term has a z in it. Can I pull out any z's at all? No, because the other ones don't have any z's in it, right? So the best we have is 2xy. What are you left with for your first term? 3x, good, because I pulled out a 2, it leaves a 3 for the 6 from the 6, right? Pull out 1x and 1y, the y is gone. How about for the next one? 4y, good, and the last one, 6yz is left over, right? So for the 4y, we pulled the 2 out of the 8, left a 4. We pulled out the x, so it's just gone because there was only one x to start with. Pulled out 1y, we're still left with 1y, right? For the last term, pulled the 2 out of the 12, we were left with a 6. We got rid of the x by pulling it out in front. We only pulled out 1y, and we didn't pull out any z's at all. So those are left. That okay? We're going to do lots more examples of these. I mean, we'll do a lot more today since we have a quiz, but we'll do more. We're going to do factoring for a long time. So it'll take a little bit to get used to it. We'll get there. An extension of greatest common factor is something that's called factoring by grouping. Looking at that polynomial that you're given on your paper, notice that there's nothing. The only thing that all the coefficients have in common is a 1, right? In particular, there's a 1 right there. so the GCF for the coefficients would just be 1. Notice there's not an x in all of them, so I don't have a coefficient of, or a factor of an x, and there's not a y in all of them, so I don't have a y either, right? So for the whole polynomial, the GCF is 1, right? There's nothing they all have in common besides 1. Does that make sense? I don't have anything in common for all of the coefficients except for 1, and in the variables, there's not the same variable in all 4 terms. However, when we do what we're called by factoring by grouping, we group a couple of terms together and see if there's any GCFs there to start with. Okay? So let's look at just the first 2 terms grouped together. Do you see a GCF for just the first 2 terms? What is the GCF? What can you pull out of the first 2 terms? A y squared is in both of them, right? If we pull that out, what are you left with in just the first 2 terms? Ignore the second 2. What do you get when you pull out the y squared in the first 2 terms? X minus 3, good. Now do the exact same thing for the second 2 terms. What do you see as a GCF in the second 2 terms? 7. If I move the 7 out, what are you left with? X minus 3. Okay. So again, both of these terms have a y squared, left us with x and a 3, so they have the x minus 3 there. Both of these terms have a 3 in it, have a 7 in it, that leaves us again with x minus 3. Okay. Now notice, do you see the same thing in this first block as you do in the second block? Yeah, I see an x minus 3, right? That now becomes the GCF of those 2 terms. We can pull out that entire chunk. If I pull out the entire x minus 3, what are you left with in that first term? And y squared. And in the second one, you're left with just a 7. This is what we mean by factoring by grouping. We've made this longer polynomial into 2 factors by doing this process where we group the first 2 and the second 2 together. That's factoring by grouping. So let's do the same thing for this next example here, and then I'll get you started on your quiz here. Let's group these 2 and these 2. Okay? In those first 2 terms together, what do you see that they have in common? There's a 2 and an x, right? I've got a 2 that divides both the coefficient, and both of them have an x in them, don't they? If I pull out the 2x just out of the first 2, what are you left with? The first term you're left with p, and the second one you're left with a q. So again, sorry, not just a q. What's left on that q? Sorry, 5q. Yeah, my bad. Sorry about that. I pull out a 2, I'm still up to a 5 there, right? Now look at your second 2. What can I pull out of the second 2? I got a 3 in both of them and a t in both of them, don't we? What are you left with after you pull out the 3 and pull out the t? P plus 5q. Notice it's just like that previous example we did, right? Now we see the exact same thing here and here, don't we? So again, we can treat that now like it's the GCF and pull it out. It's a 2-step process here. So if we pull out the p plus 5, that whole chunk, we're treating it like it's one thing. We pull out that whole chunk. What are you left with in the first term? 2x, and the second one, and the 3t. Good. And that's as good as it gets as far as we can get for factoring. All right, let's do one more. Do you see anything that all the terms have in common? This is, by the way, looking for a GCF should always be the first thing you do. Factor it out first. It's always the first thing you should look for. I will harp on that for the next 2 weeks. Okay? Do you see anything that all 4 of the constants have in common? Just a 1, right? Because that 3 causes a problem, doesn't it? Okay. Is there an X in all 3 terms? No. Is there a Y in all 3 terms? No. So there's not a GCF to pull out. The GCF would be 1. Okay. So let's try grouping. Anytime you have 4 terms in your polynomial, grouping is probably what you're going to try. Okay. Out of the first 2, what can you pull out? A 2 and an X. You pull out the 2X, what are you left with? X plus 4, right? Now, out of the first 2 examples, notice here we had an X minus 3 in both terms. Here we had a P plus 5Q in both terms. What do you think you probably want to see in the second piece? X plus 4, right? Okay. Now let's look at this. What can you pull out of this one? A Y and a 3 and a negative, right? I've got a negative in both terms, so I want to pull that out too. Oops, sorry, we said a Y. I wrote an X. Sorry about that. 3Y. What are you left with in the first term? X. Now we pulled the minus, so what are we left with in the second one? Plus 4 again, right? Yes. Yep. Yeah, so they're pulling the minus sign out too. So we pulled out the negative 3, so it pulls out the minus. Yep. Now I have X plus 4 in both of them. If we pull out the X plus 4, what are you left with? The 2X minus the 3Y. Yep, exactly. Questions on that at all? Like I said, we're ready for more of these. I'm going to go ahead and give you the practice problems. Make sure you bring these to class on Friday. So we'll go over a few of these before we go over the new stuff. And I'll hand out the quiz here in a second. But if you want to get started on trying to do some practice of these before Friday, I would go ahead and suggest doing that. No, it's just practice. And I'll post the answers to them on Moodle so you can see them. We'll go over a few of them in class on Friday, and then we'll get into new stuff as well. We'll get the quiz. Again, like I said, when you're done with the quiz, you can go.